For Inquiry 4.1 and 4.2, we're going to be investigating cellular respiration. When we breathe in air, we take in oxygen, and when we eat food and we go through digestion, we take in nutrients like glucose. So we're going to be using that oxygen from our breathing and that glucose from our digestion for cellular respiration. So what is cellular respiration? If cellular respiration is a type of oxidation, like we talked about in the Getting Started activity, then what will it require? If it's oxidation, there's a big hint in that word, it's going to require the gas oxygen. Our materials for this lab are found on page 37, and our procedures are found on page 38 to 45. We have combined two different inquiries, actually 3 different activities, to come up with this lab and this investigation. So for the first set of data, you're going to be making some observations, and the actual instructions for these are found in the Getting Started, the part about the candle on page 38 to 40, steps 5, 6, and 7. But you don't have to be concerned about the numbers 5, 6, and 7 here. These 3 lines are just lines for you to make observations. So let's switch over and look at the candle burning so that we can make our observations. So look for color changes, look for gases that we talk about so that you can make some observations. Even look at the candle burning itself and what happens to the candle could be a good observation. So I'm going to switch over and show you the candle burning video clip and slide. Okay, let me pull this up a little bit bigger so you can see it better. Sorry. Okay, here we see that it says to observe what happens to the candle as the foil is placed on top of the beaker. Carefully watch the color of the bromthiamyl blue solution over the course of the video. Okay, so we're going to watch this video clip and I'll describe some things as we go. Okay, I'm going to pause for a second. Here in this video clip, we see the setup from our lab. We have a beaker. Inside the beaker, we have a little wooden block that has a tea candle sitting on top of it, and we have lit the tea candle. The liquid that is around the tea candle is bromthiamyl blue, which starts out a bluish green color. The more oxygen it has, the bluer it will get. But as we watch the video, notice what happens to the color of the bromthiamyl blue, and also notice what happens to the candle. And that's where your observations will come from. So if you continue watching, the candle's burning in the beaker. Then we're going to cover the lid of the rim of the beaker with foil as a lid. We're going to cover it over really good. Continue to watch the flame and see what happens, and also you'll start to notice something happen to the color of the bromthiamyl blue. As you can see, the candle is getting weaker and weaker. Think about why the candle now has gone out, and that's because it could not get any more oxygen. So as we're swirling the beaker, the bromthiamyl blue goes from a more bluish color to a more yellowish color. And bromthiamyl blue is a indicator solution. In this case, it's indicating the presence of carbon dioxide. It turns yellow in the presence of carbon dioxide. So the candle was putting off carbon dioxide. It was burning oxygen, putting off carbon dioxide. And when we put the lid over the beaker, it trapped the carbon dioxide inside. It did not allow any more oxygen in. And as you can see, the bromthiamyl blue is now turning a very yellow color because it's absorbing the carbon dioxide in the air of the beaker. Okay. Now, if we go back to our lab report, right here on these 3 blanks, you need to make 3 observations from the video. In class, the kids put the color of the bromthiamyl blue to start with, and then on the middle line, they talked about what happened to the candle, and then on the last line, they indicated what color the bromthiamyl blue changed and why. Okay, for the next set of our data, we're going to be investigating cellular respiration, and in class we would have used 4 different students, but those of you at home doing this virtually, you'll only have one set of data. You will have a starting temperature of the water and the final temperature of the water. So now we're going to watch a video clip to help us with that step. I'm sorry, I forgot to show you the initial color and the final color of the bromthiamyl blue. So see how it's more blue here and it turned yellow here. Sorry, I forgot to show you that. All right, now let's look at what happens in our next segment of our activity. And I'm going to again pull this up where you can see it larger. Okay, it says what happens to the temperature of water when you blow your exhaled air into it. So if we look closely, we will see the temperature of the water before, and if you can see right here, the water is on about 21, nearly 22 degrees Celsius. So right here would be the 20 line, and this is about 1.5 over it, so about 21.5 degrees Celsius. Okay, then they're going to blow their air, their exhaled air into the water for 1 minute, and we're going to see how it changes the temperature. So as they're blowing into the water, it's going to make, of course, air bubbles. They're blowing into the water with a straw, and they did that for 1 minute. And then we took the final temperature of the water. Right here is the 30 line. Here would be 35. And it looks like it's about 36.5. So it went from 21.5 up to 36.5. So on your data table, you can go back and put 21.5 to 36.5. And as you can see, the water got warmer from the exhaled air, and that indicates to us that the exhaled air contained heat, and that heat came from our internal body temperature, which in return came from our body going through cellular respiration, burning the energy from the glucose and the oxygen, and producing energy, and one of the waste products would be heat. Okay, then we have our last part. On this, you're going to be using red to show the direction that the air is being inhaled, and blue to show the direction for the exhaled air. So let's go back and look at a video clip of this particular part of the activity. In this case, we're using a breathing apparatus. The breathing apparatus allows us to inhale and exhale air. So you need to pay attention to which side of the apparatus uses inhaled air and which side of the apparatus uses exhaled air, and why. So let's watch our video clip to see this take place. Here you see one of my teacher friends. She is helping out with this investigation. We're using a breathing apparatus. When she breathes in, she's taking up air from this side. I'll show that to you again. When she's exhaling air, you'll notice she's pushing air out. It's going through this side. And when she's breathing air in, it's coming from this side. So let's take a closer look at that. Breathe in, breathe out. Breathe in, breathe out. So the exhaled air was on our right here, and the inhaled air was on our left. So let's take a look at this a little further. And this time we have added some bromthiamyl blue to help us see this better. So if you'll notice, the bromthiamyl blue is in both containers. Remember, from what we talked about earlier, the bromthiamyl blue will turn yellow in the presence of carbon dioxide, and it will be more blue in the presence of oxygen. And you can already notice a difference here. This one is turning yellow from the carbon dioxide, and this side is turning blue from more oxygen. So she's inhaling from the side that has oxygen and exhaling back in. She's putting out carbon dioxide. Okay, so if we go back to our data, we would show with blue the direction of air coming through. So you can use your drawing tool and select blue as your color, and you can do a line or arrows to show the movement of the air down this tube and then up out this tube and out into the air. And then when she is inhaling air, she's going to be breathing in oxygen from the atmosphere, and it's going to come through here and then come back up this way, up through the tube to her mouth. So again, for the inhaled air, use red. For the exhaled air, use blue. And you can use the drawing tool to draw the directional arrows on there. Okay, when you get through with that, then for your analysis, you were supposed to compare combustion and cellular respiration. Here are a few things we came up with in class. You can pause the video and use that to help you with your Venn diagram. We used the shapes tool to make our circles, and we just made our circles overlap. It's okay if your circles are not the same exact size or shape. Then for number 2, we talked about the formula for cellular respiration. Cellular respiration takes in glucose and oxygen, glucose from the food we digest, from the nutrients, and oxygen from the air that we breathe in. And then the arrow stands for it yields or produces through the reaction, produces the products water plus carbon dioxide plus energy. Okay, and then questions 3 and 4 are some things for you to think about. And number 4, you do have some pages to read to help you to better understand how our bodies process O2 and CO2. And then on the vocabulary section of your lab, most of the words can be found in this dictionary. The ones that cannot be found in the dictionary, you can pause the video and get them from here. And then your last step, of course, is to write your conclusion. Please make sure your conclusion summarizes what is cellular respiration. Please do not, in your conclusion, tell me what you saw from the lab as far as we did this or we did that. Please make sure you describe what happened in the processes of what was done, or describe what cellular respiration is. If you have any questions, make sure you message me. I'll be glad to hear from you. Have a great day.